Problem 17. Joanna folds the number square twice as shown. Then she punches a hole through the black spot shown by the arrow. Which numbers does she also punch through? These are our options. Let's observe this problem carefully. Joanna folds the number twice. First, the middle rows overlap, bringing certain numbers together. So these are the numbers it overlaps. Then she folds it again onto towards the right side. So this numbers gets overlapped now. Now she punches it in the center of it. That means she punches it on here. So we have 20, 23, 14. So we clear the screen and see that 14, 20, 23 and 17 are our numbers which are being punched through. So our option is option B. Great job. We just solved our problem 1 for this series, which is problem 17. Now let's move on to our next challenge. Problem 18. 3 football teams participate in a sports tournament. Each team plays the other 2 teams exactly once. In each game, the winning team gets 3 points and the losing team does not get any points. If the game finished in a draw, each team gets 1 point. At the end of the tournament, which number of points is it impossible for any teams to have? Let's analyze the possible scores for any team in this tournament. Each team plays 2 matches, one against each other of the other 2 teams. In each game, a win gives 3 points. A draw gives 1 point. A loss gives 0 points. Now let's check the possible total a team can achieve. So let us start with the combination with winning. So if a team wins both the games, that means gets 3 plus 3 points. That means 6 points. If a team wins 1 game and draw 1, that means 3 plus 1 point, which equals to 4 points. Another combination, if a team wins 1 game and lose 1, that means gets 3 points for winning and 0 points for losing. That equals to 3 points. Let's start with the draw. So if the team draw both the games, that means we have 1 plus 1 point, which equates to 2 points. Draw 1 game and lose 1, which is 1 plus 0, losing 0. It equates to 1 point. And if a team lose both the games, that means it will not get anything, 0 points. Now let's bring our options here and see. So we have option A, 1. So 1 point we can achieve. B, 2 points we could achieve. 4 points we could achieve. 5, we cannot get 5 points in here. 6 points, yes, 6 points we could get. So our answer is option D, 5. And there is no way to reach exactly 5 points with this scoring system. So our answer is option D. We just figured out the points for the 3 football teams. Now I'm curious about the next challenge. Let's dive in and solve it together. Problem 19. A pyramid is built from cubes with a side length of 8 cm. An end climbed up over the pyramid, as shown by the red lines. What is the length of the path walked by the ant? These are our options. Imagine a little ant climbing up and over a pyramid made up of cubes. Each cube has sides that are 8 cm long. The ant climbs up one side, walks across the top, and then climbs down the other side. Let's figure out how far the ant walked in total. The ant does not climb straight up. It walks on a slanted path. Let's break it down step by step. First, the ant climbs 8 cm So we keep 8 centimeter. Then it walks 4 centimeter cross. So we add 4 centimeter. Then it walks up 8 centimeter, walks across 4 centimeter, up 8 centimeter, and then 8 centimeter, and come down 8 centimeter of this cube. Then it across 4 centimeter, come down 8 centimeter, then 4 centimeter, and then down 8 centimeter. So in total, 8 plus 4 plus 8 plus 4 plus 8 plus 8 plus 8 plus 4 plus 8 plus 4 plus 8 gives us 72 centimeters. So the end walk 72 centimeter in total. That's a long journey for such a tiny creature. So our answer is option C, 72 centimeter. If you enjoyed this puzzle, don't forget to like and subscribe for more fun math challenges. See you in the next one. Problem 20. Elma wants to put one of the pieces 1 to 5 in the middle of the picture so that house A is connected by road to house B and E, but not to house D. She can rotate the pieces. Alma wants to put one of the pieces labeled 1, 2, 3, 4, and 5 in the middle of this picture. And she wants to make sure that house A is connected by road to house B and house E, but not to house D. She can also rotate the piece to fit into this picture. First, let's try piece 1. When we place it in the middle, we can rotate it and see if it fits. So we see here that house A is connected by road to house E and B. So this is our one option. Let's try piece 2. We see that it connects house F and B, but we wanted to connect with E as well. So this is not our option. Let's try piece 3. We see that the road is connected between E and C, but not with B. So this is not our option. We cancel it. Piece 4. We see that A is directly connected to D, which is not our requirement. So we don't take it. Now we pick piece 5. And we see that it's being connected. A is connected to E and B and is not connected to D. So this is also our answer. So piece 1 and 5 could be our answer. So we look into this and we see option A is not, B, C, D, and E is our answer. We have completed half of the part C questions of 2022 Math Kangaroo for grade 3 and 4. Please do not forget to subscribe this channel for more solutions coming your way. Problem 21. Ahmed and Jolie started walking from point A with the same speed in the direction shown. Ahmed walks around the square-shaped garden. Jolie walks around the rectangular-shaped one. What is the smallest number of laps that Jolie could do around the rectangular-shaped garden to meet Ahmed at point A again? All right, let's break this down in a way that's easy to understand. Ahmed is walking around a square-shaped garden, and the sides of the square are 5 meters long. So if you imagine walking all the way around the square, you would add up to 4 sides, 5 meters on each side, which equals 20 meters. Similarly, Zole walked around the square, the rectangle, and adds 10 plus 5, 15, 15 plus 10, 25, 25 plus 5 gives us 30 meters. Now if we visualize in terms of laps, how much meters Ahmed and Zole walks? So let's start. So we have laps and we have Ahmed and Zole. So on the first lap, Ahmed walks 20 meters, Zole walks 30 meters. On the second lap, Ahmed walks 20 meters more, that is 40 meters. Zole walks 30 meters more, that is 30 plus 30 gives us 60 meters. We don't see any common factor, so let's have another lap. So third lap, Ahmed walks 20 more, gives us 60 meters. Zolay walks 30 more, gives us 90 meters. We see there is a common factor in Ahmed and Zolay. So when Zolay walks 2 laps, he reaches to 60 meters. When Ahmed walks 3 laps, he reaches to 60 meters. This means Zolay needs to walk 2 laps to meet Ahmed again at point A. Great job! We have figured out how much Zolay needs to walk to meet Ahmed. You have been solving some really tricky problems, and that's amazing. Keep up the great work and let's dive into the next challenge. Problem 22. 5 children ate some plums. Sophie ate 2 plums more than Lauren. Betty ate 3 plums fewer than Sophie. Claire ate 1 plum more than Betty and 3 plums fewer than Alice. Which 2 girls ate the same number of plums? Let us follow along with this question as we break it down step by step and solve it together. So let us start with Lauren. Imagine Lauren ate X number of plums. We don't know exactly how many yet, so we just use X as a placeholder. Now move on this. Sophie ate 2 plums more than Lauren. That means if Lauren ate X plums, Sophie ate X plus 2 plums. Betty ate 3 plums fewer than Sophie. Sophie ate X plus 2. Betty ate minus 3 of X plus 2. So plus 2 minus 3 gives us minus 1 plums. Let's move on to the next. Claire ate 1 plum more than Betty. So Betty ate X minus 1 and then Claire ate plus 1. 1 more than. So it becomes minus 1 becomes minus 1 plus 1 becomes 0 and it becomes X plums. She ate the same number of plums as Lauren. Claire also ate 3 plums fewer than Alice. So Claire ate fewer plums than Alice. So Claire ate X, Alice ate X plus 3 plums. So we can see that Claire and Lauren ate X plums, which means they ate the same number of plums. The correct answer is option A, Claire and Lauren. So we found that Claire and Lauren ate the same number of plums. Great jobs following along with that. Now let's move on to the next problem and see what new challenge can be solved together. Problem 23. A farmer has 9 bags with potatoes as shown. The numbers on the bags show their weights in kilograms. He wants to split them in 3 groups of 3 bags each so that each group weighs the same as the others. Which of the following bags will be the same group as the bag that weighs 6 kilograms? These are our options. Again, let's solve this step by step. The farmer has 9 bags and the weights of the bags are 1, 2, 3, 4, 5, 6, 9, 13 and 17. Let's find the total weight of all the bags. So we sum all those weight and we get 60 kg. Now the farmer wants to split them into 3 groups of 3 bags each. Since there are 3 groups, we divide the total weight by 3 to find the weight of each group. So we divide 60 by 3 gives us 20. So each group must weigh 20 kilograms. Now we are given that one of the bag weighs 6 kilograms. We need to find which other 2 bags will also sum up to 20 kilograms when paired with the 6 kg bag. So first we need to find 3 groups of three numbers that each add up to 20. So let's start with number 17, the highest one, and see where 17 can fit in to make it 20. So we say 17 plus 2 plus 1 gives us group 1, and that is 20. So we cancel 1, 2, and 17. Now let's pick group 2. Group 2 we pick biggest is 13. So 13 plus 4 gives us 17. 17 plus 3 gives us 20. So we form group 2. Now group 3, the remaining are 9, 5, 6. So we form 3 groups whose sum is 20. And we observe that group 3 has 9, 6 and 5. That means 6 kg bag is in the same group as 9 kg and 5 kg. That means our answer is option D. Now that we have solved this one, we have made it to the last problem of this series. Let's tackle it together and finish strong. Problem 24. Which of the following nets could be folded to a cube like this? These are our options. The key here is that the 5 of the faces are square and one of the faces is connected to 2 triangle faces. So we need to look for a net where we have 5 squares arranged in a way that allows the 2 triangle faces to connect with one of the squares. So let's pick option A. We keep this square as a base. We bring it as a wall on the side. We bring this as a triangle coming up. This triangle fits this, but this would not be a correct place. So we remove option A. Option B, we take it as a base. We bring this, fold this to this side, fold it up. This square come as on the top. This would be a triangle facing this one, and this triangle would come this. So option B is our correct answer. Let's see other options as well. We take it as a base, we fold this, this comes up top. This would be a correct triangle, but this is not a correct one. So we remove option C. Option D, we take it as a base, we fold this one, fold this one has come as top, and these 2 triangles are not placed at the proper place. So we remove option D. Option E, we have a base, we fold this one, this, and this is totally at the wrong place. So we remove option E. So our correct answer is option B. With this, we have finished part C of the 2022 Math Kangaroo Challenge for grade 3 and 4 together. It was a 5-point puzzle and it was the last in our series. You all have done an amazing job solving these tricky problems. Don't forget to hit that like button and subscribe for more math challenges. And make sure to check out next puzzle series. Keep up the great work and see you in the next video. Thank you.